Substitution reactions are classified into three types: electrophilic, nucleophilic, free radical. So we have started electrophilic substitution reactions 1. Electrophilic substitution reactions. Right. So what are electrophilic substitution reactions? The reaction in which the substitution reaction which is initiated by electrophile, or one electrophile is replaced by another electrophile, is called electrophilic substitution reaction. And it is the property of benzene and its derivatives. So benzene and its derivatives undergo electrophilic substitution reaction. Now tell me, why the benzene undergo electrophilic substitution reaction? So first of all, tell me, benzene is electron rich or electron deficient? Benzene is a electron rich. So due to presence of 3 pi bond, it is a electron rich. It means benzene act as a nucleophile. Since benzene act as a nucleophile, it has pi bond, it's supposed to undergo electrophilic addition, no? Like alkene having carbon-carbon double bond, electron rich, and they undergo electrophilic addition reaction. So like similar to alkene, now benzene has even more double bond compared to alkene. So it is more and more electron rich. Since it is electron rich and nucleophile and having double bond, it's supposed to undergo addition reaction, but not. Addition reaction is the property of unstable compounds like alkene and alkyne. This is a stable compound. So even though benzene has 3 pi bonds, it is not an unstable compound, it is a stable compound. Due to stable compound, it does not undergo addition reaction, undergo substitution. Then why benzene is a stable? Because of aromaticity. So benzene has aromaticity due to presence of 3 pi bond. It follow aromatic rule, therefore it is aromatic. So therefore now we understood that benzene and benzene compound undergo electrophilic substitution reaction. Then electrophilic substitution reaction takes place in 3 steps. 1, tell me, 1, formation of electrophile, 2, attack of electrophile, 3, deprotonation. So already we have written general equation also, right? Next is types. We need to start types of electrophilic substitution reaction. So have written all types written, and tell me, first one is, okay, write down, halogenation of benzene. Okay, now let us take chlorination. Chlorination of benzene. And tell me, what is the chlorination of benzene? Benzene reacts with chlorine, Cl2, in presence of any Lewis acid. What are the Lewis acids? Electron deficient species, no? You can take AlCl3, FeCl3, SnCl2, okay, titanium tetrachloride, etc. We take AlCl3, anhydrous AlCl3, which is a Lewis acid. So therefore benzene plus chlorine in presence of anhydrous AlCl3. We know that benzene has 6 carbon, 6 hydrogen. So any one of the hydrogen replaced by chlorine. So chlorine, there are 2 chlorine, Cl. So 1 chlorine, 1 hydrogen, HCl come out, and the product is chlorobenzene plus HCl. Okay. Then here important is questions based on mechanism. So what is the mechanism of this chlorination? It takes place how many steps? 3 steps already we have studied. Step 1, formation of electrophile. Tell me. So first one is formation of electrophile. Here AlCl3, which is reacts with chlorine. So we know that chlorine undergo heterolytic cleavage, it gives Cl++, Cl-. Okay, now tell me, AlCl3, which is combined with Cl-, it forms what? AlCl4-. AlCl3 plus Cl-. AlCl4-, plus what is the left? Cl plus. This Cl plus is a electrophile. Okay. Therefore, halogen reacts with Lewis acid to produce the electrophile. Then what is the importance of Lewis acid? Lewis acid produces electrophile. It helps in producing electrophile. Next is step 2. In step 2, there is a attack of electrophile on benzene ring. So electrophile attack on the benzene ring. Now let us take benzene ring. Right, on benzene ring there are 6 carbon, 6 hydrogen of course. Now we have studied this pi bond may shifted on any one carbon. Suppose this pi bond shifted here, there is of course hydrogen each carbon, then this carbon gets negative charge, this carbon get what? Positive charge. Now tell me, our electrophile Cl plus attack on which carbon? Whether positive carbon or negative carbon? It should be on negative carbon, right? Then tell me, attack of electrophile on this carbon and shifting of electron takes place on same that carbon, which is called plus E effect, plus E. So therefore you can also take, it is also example for a plus E effect. So therefore now tell me, what is the intermediate? Intermediate is this benzene ring containing positive charge, and it undergo resonance. That we have written resonance structures, need not write again and again. It undergo resonance, you will get a resonance hybrid which is called sigma complex. Okay, it is step 2. Next is step 3. Step 3 is deprotonation. Right. So benzene ring carry, here positive charge. Now in presence of AlCl4 minus, which is formed in first step. Okay. Can you tell me? This AlClO4, can we write AlCl3 plus Cl minus? We can write. Now tell me here, this sigma bond shifted as a pi bond, then which is come out? H plus. This H plus plus Cl minus HCl, and you will get benzene ring attached to chlorine plus Cl. Now hydrogen H plus plus Cl minus HCl plus AlCl3 is regenerated. Tell me, in the first step AlCl3 is used, and the last step AlCl3 is regenerated. Therefore what is AlCl3? The role of AlCl3 is it is a catalyst, because catalyst, what is the nature of the catalyst? A catalyst is a substance which cannot be used in the reaction. It cannot be consumed. It is used, it is regenerated. So this is a halogenation, chlorination. Now here 3 points are important. 1, in halogenation of benzene, what is the electrophile? Cl plus, that is X plus. Electrophile is X plus, halonium ion. What is the reagent? AlCl3 and Cl2 or X2. Okay. Next, second one is nitration, no? Nitration of benzene. So what is a nitration of benzene? Benzene reacts with nitration mixture. What is a nitration mixture? Concentrated HNO3 and 2 moles of sulfuric acid. Remember moles also. Benzene heated with concentrate nitric acid and sulfuric acid, which is called nitration mixture. It forms nitrobenzene plus H2O will be found. Okay, then what is the mechanism? So in mechanism, step 1, it is a formation of electrophile. Tell me, what is a electrophile in this reaction? Obviously NO2, no, NO2 plus. Then how it is formed? Say it is HNO3. You can write like this: OH negative, NO2 is positive. And in presence of sulfuric acid can be written HSO4 minus. There are 2 moles HSO4 minus. Now tell me, you remove this OH, ಏನು ಬರುತ್ತೆ ಹೇಳಿ? OH plus H plus H2O, H2O plus H plus, yes, H3O plus hydronium ion plus NO2 plus 2 moles of HSO4 minus. Now this is called nitration mixture. The mixture of concentrate nitric acid and 2 moles of sulfuric acid is called nitration mixture, 1:2 ratio. This nitration mixture produces the hydronium ion, NO2 plus HSO4 minus. Now here question is, which is electrophile? So electrophiles are electron deficient species. It is electron deficient, positive. It is also electron deficient, positive. Which is electrophile? In electrophilic substitution, here NO2 is substituted, no? Means substituted. That means NO2 is placed here. That means it should be it must be NO2 only. Therefore not H3O plus. NO2 is a electrophile. Okay. Next, second step. Tell me, what is second step? Attack of electrophile. In attack of electrophile, there is a benzene ring containing 6 carbon 6 hydrogen. Let us take one hydrogen, I'll show here. Then NO2 plus. Come on, tell me where the NO2 plus attack. NO2 plus attack on any carbon, because all the carbon atom on hydrogen on benzene is same. Now let us NO2 attack here. When NO2 attack here, pi bond shifted on same carbon, no? Which is a Plessy effect. So therefore now which carbon gets positive charge? Adjacent carbon. So here hydrogen NO2 get substituted. Okay. Then which is undergo resonance? That is, you can write resonance structures. Next is step 3. Deprotonation. In deprotonation, let us take benzene ring having positive charge. Right. Now this is in presence of H3O plus and HSO4 minus. There are 2 HSO4 minus. Come on, tell me. This sigma bond shifted as a pi bond. H plus is come out. When H plus will come out, you will get the nitrobenzene is the product, plus along with nitrobenzene, what is the product? H plus plus 1 mole HSO4. What do you get? H2SO4, and this H3O plus also produce 1 proton, which gives what? 2 H2SO4 plus H2O. So sulfuric acid is beginning it used, and again it is regenerated. Therefore which is a catalyst in this reaction. Therefore, in nitration of benzene, what is electrophile? NO2 plus. What is the reagent? Nitration mixture. Next, sulfonation of benzene. Sulfonation of benzene. So what is the sulfonation of benzene? Benzene heated with concentrated sulfuric acid. Benzene plus concentrated sulfuric acid, it is at or above 60 degrees Celsius, right? So one of the hydrogen in sulfuric acid can be written OH, HSO4 minus, right? OH ಏನು ಬರಿಬೋದು SO3 H H2 SO3 and O SO4. So remove the water and the product is benzene sulfonic acid. Benzene sulfonic acid mechanism. It is important. Previously question appeared. Step 1, formation of electrophile. Tell me here. In this formation of electrophile, there is a sulfuric acid. Sulfuric acid H2SO4. It gives rise to, you can write sulfuric acid H2O SO3. Yes or no? Very bada. Here, which is negative, which is positive? H2O is negative. SO is positive. Both are neutral. Water is neutral, no? You let water bardu positive bartira. Uchantane. SO3 plus H2O. Both are neutral species, right? So which is electrophile now? It must be electrophile, SO3, no? It is a electrophile, right? Next, step 2. So what is the step 2? Attack of electrophile. Not e reaction ಸ್ವಲ್ಪ change ಬೇದಾಗಿರುತ್ತೆ. It is little difference will be there. See carefully. Right. Now SO3 electrophile is added. Right. Tell me now, when SO3 electrophile is added to any one carbon, what happened? Let us add SO3 here. Obviously electrophile is what? Electron deficient. When electron deficient, when it is, as soon as attack this carbon, it tried to pull this pi electron, so that pi electrons also shifted this side. It is also plus C effect. Then adjacent carbon get positive charge. Here H, it is SO3. Now tell me, SO3 become what? SO3. Now there we have taken, see, here we have taken neutral, no? Where here, yes or no? NO2, actually NO2, where it is? No, sorry, here NO2 plus, no? NO2 positive attacks here, it become NO2 neutral. Why? These pi electrons are, no, it is taking pi electrons, so that it become neutral. We are not written positive and negative charge, right? Yes or no? Here also same. Hallucination. We erase now. Okay, tell me now. It is SO3. When SO3 is attack here, what happens? It becomes negative. Why? Because this pi electron shifted on this carbon, nothing but it is SO3 is attached here, that negative charge shifted on this SO3, right? That's what this is different. Next is step 3. What is the step 3? Deprotonation. And moreover, tell me here in all this reaction, which is RDS? Attack of electrophile. No, here attack of electrophile. This is RDS. In sulfonation, this is RDS, rate determining step, attack of electrophile. So therefore now in deprotonation, tell me. What I mean? Same, this sigma bond shifted as a pi bond, it become positive. Now this H plus shifted here only. So therefore it become SO3H. That's it. Sulfonation of benzene. So what is the electrophile in sulfonation? That is a neutral electrophile SO3. Do you remember what are the criteria for the nucleophile, or what are the conditions for the nucleophile? In which case you can say it is nucleophile? One, all the negatively charged species, right? All negatively charged species are nucleophile. 2, the neutral species which are having one or more lone pair of electrons also act as a nucleophile. Next, multiple bond, right? The neutral molecule which are having multiple bond with more electronegative element, that is SO3, no? SO2, SO3, CO2. Yes or no? They are also nucleophile. And carbon-carbon multiple bond, nucleophile only. Alkenes, alkynes, nucleophile. Carbon-oxygen double bond act as both electrophile and nucleophile. Aldehyde ketones and cyanides can act as both electrophile and nucleophile. Therefore, SO3 we have studied, it is nucleophile, right? It is a neutral nucleophile. Next, Zwitter ion is different. The concept of Zwitter ion is what? The species which are having both polarity, positive polarity, negative polarity. There is a polarity, there is charge. This is what? Nucleophilicity. Electron giving character, electron taking character. Right? That is a different. Both are different. Next is Friedelcraft Alkylation. Ahead. It is SO3 is a neutral, but we are saying it is a nucleophile, no? Nucleophile. So what is the meaning of nucleophile? Electron rich species. Nucleophile is always electron rich species. So it is, since it is electron rich, how can attack on? Tell me. No, it is not nucleophile. Electrophile, no. Did I say nucleophile? It is. What I say? No. We are studying electrophilic substitution, no? It's electrophile. Have written like that anywhere? No. Okay. It is electrophile. Electrophile. See, no. I gave example of nucleophile correct only. Which are the nucleophile? But that nucleophile not related to this. It is not nucleophile. It is electrophile. So, which are electrophiles? The species which are having positive charge. Next is electron deficient. Which neutral molecule which are having tell me electrophile. What are electrophiles? I'll clarify. 1. All the positively charged species, right? All positively charged species are electrophile. 2. Yeah, the species in which central atom has vacant d orbital. Or next, the species in which central atom has less than 8 electron. Or alli idu madidhu now, right? There we have given the species, the neutral species in which central atom has multiple bond with more electronegative element, that is electrophile. Okay. It is not nucleophile, it is electrophile. In 4 category we have studied electrophiles. First category is all positively charged species. Second category is vacant, that is I think third. Second one is less than 8 electron. Third one is vacant d orbital. Fourth one is neutral species which are having multiple bond with more electronegative element. But the neutral species which are having multiple bond with carbon is nucleophile. Carbon triple bond nucleophile. But it is a like sulfur oxygen, sulfur dioxide nucleophile, CO2, SO3, Cl2O7, right? P2O5. These are all electrophiles. Okay, if you have written, you change it. If you have not written, but you make it correction, it is a electrophile. Now tell me, it is electrophile. Now this electrophile should attack on electron rich, no? That's what is possible. Next is Friedelcraft alkylation. Friedelcraft alkylation. So what is a Friedelcraft alkylation? Benzene. Benzene reacts with alkyl halide. Let us take methyl chloride. Methyl chloride in presence of any Lewis acid, you can take AlCl3 or FeCl3 etc. Anhydrous AlCl3. Tell me, in benzene there are 6 hydrogen, any one hydrogen replaced by what? Methyl group. What is the product is? Methyl benzene, no? Toluene plus HCl. What is the mechanism? Step 1. Formation of electrophile. Tell me. So what is the formation of electrophile? Their methyl chloride reacts with AlCl3. Okay, Cl minus CH3 plus Cl minus AlCl3 gives us to AlCl4 minus plus CH3 plus. Here important is you will get carbocation. See, in Friedelcraft alkylation, carbocation is the intermediate. So if the carbocation formed as intermediate, it may undergo rearrangement. So therefore, carbocation intermediate comma, it may undergo rearrangement. Okay, fine. Step 2. Attack of electrophile. Now let us take benzene ring. Electrophile is here methyl group, carbocation. Come on, tell me. When methyl carbocation attack on this carbon, right, towards same carbon, pi bond or pi bonds will be shifted, which is a plus C effect, and of course it is a RDS, rate determining step. Yes or no? This is rate determining step, and it is a benzene carbocation intermediate. Next is step 3, deprotonation. In deprotonation, let us take benzene carbocation. Now come and tell me. Now this reaction takes place in presence of what? AlCl4, but AlCl4 produces AlCl3 plus Cl minus. Now this proton shifted here, H plus will come out, bond shifted here, therefore the methyl group gets substituted, and AlCl3 plus H plus Cl minus HCl. Okay, but only important is carbocation intermediate. This is, we have preparation of, in phenol there is a reaction, benzene plus propyl chloride in presence of FeCl3, it gives A. This A reacts with oxygen 1 followed by hydrolysis, H2O gives B. What is A and B? This is the preparation of phenol we have in this reaction. Can you tell me? So benzene plus propyl chloride, N propyl chloride. So what is the carbocation? Primary carbocation. Then it undergo further rearrangement to form secondary carbocation. Therefore it forms secondary carbocation. That secondary carbocation attack on benzene ring, you will get cumene. Yes or no? Cumene. So therefore A is a cumene. Next, this cumene undergo oxidation followed by hydrolysis in acidic medium. So this hydrogen replaced by OH. Now the whole group is replaced by OH. You will get phenol. So B is a phenol. One of the important method of preparation of phenol. Friedelcraft acylation. Tell me, in Friedelcraft acylation, benzene reacts with acid chloride. Let us take RC double bond O Cl, acid chloride. It is also in presence of any Lewis acid. Tell me, this one hydrogen replaced by acetyl group or acid halide group, which gives rise to acetones. Plus HCl. Tell me mechanism. Step 1. Acid chloride plus AlCl3. Cl minus, no? This bond is broken here. What do you get? Electrophile plus AlClO4 minus, no? Step 2. In step 2 there is an attack of electrophile. So this electrophile attack on this carbon. So as soon as electrophile attack, what happened? Pi bond also shifted towards same carbon, plus C effect and RDS. Therefore intermediate is this, H will be there, C double bond O, or step 3, deprotonation. Tell me, in deprotonation there will be a AlCl4 minus which gives rise to AlCl3 plus Cl minus. This pi bond, sigma bond shifted as a pi bond, H plus will come out, H plus plus Cl minus HCl, then you will get aromatic ketones plus HCl plus AlCl3. If you understand one equation, all are just similar. Questions are based on this important. Take the 4 columns. So name of electrophilic substitution reaction, second one reagent, third one electrophile, fourth one product. 1 halogenation, 2 nitration, 3 sulfonation, 4 Friedelcraft Alkylation, 5 Friedelcraft Acylation. Tell me. So in halogenation, what is the reagent? AlCl3 plus halogen. No, halogen is, or else you can take AlX3 plus X2. Nitration, HNO3 plus H2SO4. H2SO4. It is alkyl halide plus AlX3. It is acid halide plus AlX3. Electrophiles, here is X plus, Cl plus, Br plus, I plus. Here is NO2 plus. Here is very important SO3. This is only neutral electrophile, not nucleophile. Neutral electrophile. Next is carbocation. Next is products. Will you write? What is the product here? Halobenzene. Here is nitrobenzene. Here is benzene sulfonic acid. Here is alkyl benzene. Here is aromatic acetones.